So we'll go ahead and begin today's webinar now on on-site and containerized thermal treatment. This is Grant Geckler from TPS Tech. So on-site or containerized thermal treatment, the idea is nothing new. Thermal treatment on-site of contaminated soils and media has been successfully used worldwide, beginning first in the United States at a U.S. Superfund site in Maine more than 25 years ago. What has changed over the course of the last 25 years is the technologies that are amenable to meet on-site thermal treatment needs. Some of the more traditional technologies that people might be familiar with include larger thermal desorption, indirect fired, rotating kiln plants. But there have been a lot of advances to both improve those traditional technologies and have inventions such as the TPS Tech system to provide a more modular and an alternative technological means to accomplish on-site soil and media treatment via thermal desorption. So to begin, the TPS Tech system is based on a technology of thermal conduction heating. This means that there is no direct contact between flame and soil. It also means that there is not a continuous throughput of system. What this does mean in practice is that soil is generally treated in cells, in piles, or in containerized structures whereby that soil or media is heated from ambient temperatures up to the desired target treatment temperature. That desired target treatment temperature will be dictated on the types of contaminants being treated and the final remedial goal or endpoint for the soils at the end of the project. The size of these cells or containerized structures can be highly variable and is quite flexible. It means in concept and in practice that soil volumes ranging from a few hundred tons all the way up to hundreds of thousands of tons can be treated in these scalable formats. Now, in this general depiction, a soil area is being treated in a pile-type structure with horizontal heater wells and vapor extraction wells inserted through the contaminated soil pile. The heat source originates at each one of the several horizontal thermal conductive heater wells, and the heat then propagates through conduction and radiation away from the heater wells and uniformly through the entire soil treatment mass, so that at the endpoint of the project, a uniform heating of the treated soil has been attained. And during this heated process, the several extraction wells are extracting either vapors or a combination of vapors and liquids from the soil pile that's being treated. In many cases, the extracted vapors from the soil mass can be simply directly distributed back to the several heater wells where those vapors are destroyed via combustion or thermal oxidation. And this also means that their BTU, or their energy value, is adding to the energy balance of the entire remediation project. So for this type of pile thermal conductive heating, we are generally specifying either propane or natural gas as the primary fuel energy source for the remediation project. Of course, a small amount of electricity will be required for the vapor extraction of any vapors and also extraction of any liquids from the treatment mass. In remote areas, this is simply performed by specifying an appropriate generator for the provision of temporary electrical supply. With this technology, soil treatment temperatures ranging from the boiling point of water all the way up to above 400 degrees Celsius is possible. Of course, the desired or appropriate target treatment temperature will be dictated first by the type of contaminant and then secondarily by the desired endpoint or remedial goal for the treated soil. Many VOCs, including VTEXs, can be treated at the boiling point of water with the addition of steam stripping that is attained naturally at that 100 degrees Celsius temperature. For some of your longer chain hydrocarbons, a higher or a superheated temperature will be required. This means a temperature above 100 degrees Celsius and sometimes approaching 225 degrees Celsius will be required. For some of your higher boiling point compounds, such as dioxins, PCBs, and chlorinated pesticides, a target treatment temperature approaching 300-325 degrees Celsius will be appropriate in order to obtain residential type standards for the treated soil. You can see a side view of our heaters and adjacent vapor extraction recovery well at a former project that was performed last summer. You can see here the heating of the soils from the thermal conductive heating well and a visual glow of the conductive radiation being transferred from the thermal conductive heating well to the surrounding soil. This is not an open source of heat. This is simply the visualization of that heat radiating away from the totally enclosed thermal conductive steel heating well to the surrounding soil area. A quick case view briefing here. This is a recent project in a smaller format, a pilot study format, to show you what a smaller or a pilot study project visually looks like. This particular ex-situ batch thermal remediation was performed on soils impacted by chlorinated pesticides, specifically DDT, DDD, and DDE. The combined average soil concentration of those pesticides in the beginning soil just exceeded 1,000 mg/kg. The goal for the pilot study was to substantiate this technology was effective to reduce the soil concentrations to below 50 mg/kg chlorinated pesticide content. We attained a target treatment temperature just above 300 degrees Celsius over the duration of the 44-day pilot study, active heating. And the average result upon confirmation sampling was far below the goal. We attained less than 3 mg/kg at the end of the project, which is substantially less than the stated goal of 50 mg/kg. So this is a good example of a small pilot study application for a high boiling point compound. On to our next example here. This soil in Europe was affected by heavy hydrocarbons and polycyclic aromatic hydrocarbons, with some NAPLs being present. The concentrations above 60,000 mg/kg were treated in a period of just under 40 days at a target treatment temperature of 200 degrees Celsius using 25 thermal conductive heater wells with individual heaters. The energy source for this project were mobile tanks of propane. The remedial goal was attainment of total hydrocarbon and PAH values less than 1,000 ppm, and this was confirmed with a round of 21 soil samples at the conclusion of the project. You can see a picture here of the construction of the ex-situ in-pile type soil remediation project. No specialized equipment is necessary. Usually your standard back scoops and tractors will be able to construct the soil pile in this lasagna type format. See a close-up here of the finished soil pile, and the covering that you see here is a thin layer of high R value covering of refractory concrete. This has two purposes. The first purpose is the conservation of energy in the form of insulation to mitigate heat loss from the treated soils. And the second in this application was to prevent any rain or atmospheric water from entering the soil pile during the treatment. And again, you can see the smaller vapor extraction and recovery wells. And you can see the routing of these vapors from the small diameter vapor recovery wells back into the individual heater units where those extracted vapors are being thermally oxidized in the heater process. This does have the direct implication that for hydrocarbon projects, no standalone or separate vapor treatment system is required for the on-site remediation. Another PAH case study is from approximately 3 years ago in an urban area. The source of the contamination was from a historic rail spur. And again, we had PAHs, including creosote, treated on-site in this pile for approximately 37 days at 200 degrees Celsius, a smaller volume of approximately 1,000 tons. And again, the desired remedial result ended up being 250 parts per million, which was, again, substantially lower than the goal set at the initiation of the project. This technology has also been successfully demonstrated in very remote and off-grid locations. This particular project was conducted in a remote area of Africa for a large oil and gas company. The specific soil being treated is from the drill cuttings and decommissioning of oil wells in the area. And it also contains not only crude oil, but also high amounts of diesel contamination from those activities. Its consistency is mostly clay. Over the course of the 5 to 6 week remediation, target treatment temperatures of 200 degrees Celsius were attained until the soil sampling showed concentrations less than 10,000 parts per million for total hydrocarbons. This is a picture of a very, very fine grained lithology before the initiation of on-site thermal treatment. This is at a soil recycling facility. And another picture showing the soil treatment technology being implemented in that same pile of soil with minimal construction effort. Another hydrocarbon case study showing gravelly sands being treated in an ex-situ format. Again, here you can see the propane tanks that were mobilized on site for the primary energy source during this remediation project. And an even more recent case study of diesel-impacted soils. This project is in Southern California, recently obtained a no further action letter. The soils were excavated as part of an emergency action due to a leak from a very large above-ground storage tank. The excavated soils had to be treated. There was a decision by the client to treat them on-site rather than transport them to a local waste facility. So TPS Tech worked with the client to install these horizontal heater wells. And a remedial goal of less than 100 parts per million for total hydrocarbons was achieved in order to obtain the no further action letter from the regulators in the county and the state of California. Now, going beyond the soil piles that we have been talking about thus far, there are many applications where there is a desire to have a semi-permanent type soil thermal treatment structure whereby soil can be loaded and unloaded to repeat the treatment over a course of several batches. So a very simple method of constructing a several batch method temporary facility is by using simple modified shipping containers or Connex boxes to form the semi-permanent on-site soil treatment structure, whereby first a concrete or cement pad is put into place, then the structures are aligned, drain pipes go in the bottom, soil is loaded into the structure, the horizontal wells are inserted horizontally through one of the four sides of the containerized structure, and then a reusable top insulation cover is placed over the final soil, and thereby afterwards the heating is initiated. Demobilization and extraction of the treated soils is accomplished, of course, in the same method that the soil was first put into the containerized structure. This picture in this case study from a recent on-site treatment shows what a similar containerized on-site structure appears like. And these structures can be used either one time, but more commonly they are used for a medium to long-term duration where several batches or periodic batches of media or soils are treated on site. In this particular case study, soils were not treated. Instead, a mixture of sludge and steel scales were treated on site. They were contaminated with a sludge of mineral oil. And the desired outcome here is unique in that TPS Tech's on-site system was used to separate out that sludge mixture. And what I mean by that is over 90% of the mineral oil from the sludge mixture was extracted in liquid form and recycled at the facility. As this sludge and steel scale mixture was heated, the viscosity of the mineral oils and naphtha oils was drastically reduced, lending itself to the physical draining and extraction of the naphthals and oils, which were then collected and, as mentioned, recycled at the facilities. At the end of the thermal cycling, the steel scales were also removed from the treatment structure and sampled. The steel media was treated to a point where it could simply be also reused and recycled at this manufacturing facility. So the end result is that some propane was used for the heating of this treatment structure, but at the end of the project there was no waste that left the site. The thermal structure simply separated the oils from the steel scales, and both of those streams were independently recovered and recycled after the project. Individual internal containerized treatments are also used for batches or for on-site treatability studies. This shows a roll-off Connex container that has TPS Tech horizontal heating and extraction wells mounted horizontally through it, as you can see on a side view in the bottom right-hand corner picture. This allows the container to be filled with the contaminated soil or media, quickly covered with an insulated barrier, and then treated at between 9 to 25 days, depending on the beginning moisture content and the desired target treatment temperature. At the end of that thermal cycling, the media or soils is then emptied from the containerized bin and used as backfill on-site or transported off-site for non-hazardous disposal. Units as large as 53 feet in length are available, and projects can use simply one of these containerized structures, or they can use any multiples of these structures. In many cases, we've specified the use of more than a dozen of these containerized structures for continuous batch soil treatment needs at facilities and remediation projects. And again, you do not necessarily have to treat soils, also mixtures of waste, steel, sludges, and other types of contaminated media can be treated in these containerized units. Well, I'll end the last case study here with a ex-situ pile type treatment of soils, but the contaminant that was remediated in this particular case study is very unique. There were no chlorinated nor hydrocarbon contaminants. This soil was in fact contaminated by mycobacterium, including high concentrations of both leprosy and tuberculosis viruses from former laboratory testings. A sterilization of the soil was accomplished at 100 degrees Celsius, and final soil conformation sampling after a month of heating showed that over 99% of that mycobacterium had been destroyed, allowing the soil to remain on site and be deemed non-hazardous for direct contact risk standards. So with that, I will leave this webinar open for questions from the audience. And I will begin right now answering some of those questions that you have typed in. Again, if you have not yet typed in a question, you can do so at the bottom of the GoToWebinar tool tab. where it is denoted as questions. So the first question here is, what is the general cost per ton for soil treatment of pesticide contaminated soil? Well, the exact cost will be very dependent on the location of the project, the beginning moisture content of the soil, the volume and mass of the soil to be treated, and of course, what the remedial goal for the final treated soil will be. To give you an understanding, for larger projects, the total cost will be less than $200 per ton of soil, sometimes even approaching $150 US per ton. For very small projects, such as pilot studies, the corresponding cost will be a little bit higher per ton of soil treated, and some pilot studies range from $250 to $350 per ton for on-site soil treatment, and guarantees for the remedial outcome and final sampling of those soils are available from TPS Tech. Some petroleum hydrocarbon or lower temperature, lower energy applications can be accomplished at or below $100 per ton. Of course, as I mentioned, there is an economy of scale that is involved in our technology that is very similar to the economies of scale that are attributable with other technologies as well. Second question here, how is the target temperature monitored? Our target treatment temperature is monitored in a three-dimensional format vis-a-vis soil thermocouples that are placed throughout the soil. So during the construction of the soil pile or the soil structure, there are thin wires that are laid through the soil at different areas and different sections of the soil. And these thin wires are referred to as thermocouples. They are connected to our PLC monitoring system, and the temperatures at those thermocouple points are continuously uploaded to our system and available 24/7 in real time via a secure FTP website login. And a three-dimensional plot of the soil being treated is available so that three-dimensional heat flux and temperature throughout that soil mass is always available for monitoring and reporting of the remedial project. Another question, if the soil is covered by a concrete cap, how is the target concentration monitored? So the progress of the soil remediation is monitored by extrapolated and direct information. Our kinetic model of the contamination is linked to residency time and temperature. This model is graphed and tracked versus the actual temperature profile of the soil. Also, the CO, CO2, and hazardous pollutant level of extracted off-gases are periodically measured, and the concentration of those extracted off-gases from the soil pile gives a very reliable leading indicator of the remaining contamination left in the soil. And this will give us an idea of when it is appropriate to take confirmation soil sampling. When the client and TPS tech deem it appropriate to take a direct measurement of the treated soil, a horizontal or slant direct push instrument is inserted through the concrete insulation into the soil, whereby a split spoon sample of the treated soil is removed, cooled in an ice bath, and then sent to a laboratory for soil conformation sampling and testing. Another question here is, how are liquids recovered, including apples, from the soil? When there are liquids such as naples that can be recovered and should be recovered in liquid format from the treated soil, there will first be a series of small drains that are inserted at the bottom of the soil, and also some liquid drains throughout the remainder of the soil mass. Those drains will also be under a negative vacuum, and the resultant recovered or drained liquids will be sent to a separate NAPL liquid collection tank, where they can either be recycled again on site or characterized for off-site handling. Another question here, generally, how much energy is used per ton of soil? Again, this will depend highly on the beginning moisture content of the soil, and will also be dictated on the specified target treatment temperature of the soil being treated. Generally, the range is between 125 kilowatt hours and 220 kilowatt hour equivalents of energy will be used per ton of soil treated. And again, this energy is either supplied with mobile propane tanks or with a supply of natural gas. Another question is, can you explain what happens to the air that has just been heated to burn off the VOCs, i.e. where is that treated air then sent? The vapors that are introduced into the heaters for thermal oxidation are extracted through the exhaust of the thermal combustion heater network and exhausted to atmosphere. Basic air monitoring protocols, such as using a PID or an FID, can be used to periodically or continuously monitor the efficiency of that thermal oxidation process in order to have data necessary to comply with local air permitting standards. I must explain, of course, that that type of in-well thermal oxidation is not used for chlorinated compounds generally. For chlorinated compounds, generally those vapors are extracted from the soil and then treated with a more traditional system. For low concentrations of chlorinated compounds, we use a primary heat exchanger to cool the vapors, and then we use a vapor phase activated carbon for scrubbing or cleaning of those vapors before that airstream is sent to atmosphere. For high concentrations of chlorinated off gas, when there is quite a large amount of mass to be removed from the soil in the vapor phase, a system known as C3 technology is often used. That C3 technology system is a compression cooling condensation system whereby the extracted off-gas vapors are sequentially cooled down to an effective dew point of below 120 degrees Celsius, whereby any contaminants are essentially liquefied from the vapor stream and recovered in a liquid form for on-site reuse or most often off-site recycling or disposal. That C3 technology system has a PLC network that is directly linked into the PLC system for the Ex-Situ thermal treatment unit. Well, it looks like that is the totality of the questions received to date. Please do contact me directly. Here's my email address. If you have any follow-up questions, comments, or general feedback related to today's webinar. I thank all of the attendees for participating and listening in to this event. I hope it was informative. And please do, again, feel free to contact me directly via email. Thanks again to everyone and have a wonderful afternoon.